We look at this first example here. If you look to solve for our variable y, and we isolate our radical, which we have already done, we undo our radical, and we do that by squaring both sides, we would get the equation y squared is equal to negative 17y minus 60. And now this is no longer a linear form, this is a quadratic equation. Okay? And so if you were working to solve this, you have multiple terms with different degree variables. So you're going to move everything to one side. So we'll move the add 17y and add 60 to both sides. We'll now solve this as a quadratic equation. Factoring is the easiest method. The two factors of positive 60 whose sum is 17, plus 12 and plus 5. And so we get two possibilities for our solutions here, negative 12 and a negative 5. We do need to plug these in. We're dealing with an even index radical. So when we test a negative 12, we see is negative 12 equal to, and would it even matter? Do we need to go any further than this? Can negative 12 equal the square root of anything? No, it can never be a negative, right? So that's extraneous. What about negative 5 equals the square root of? Is that even a possibility? No. So those are both extraneous solutions. And so the answer would be does not exist. Right. As you're working through this, your radical's already isolated, so we can undo the radical by squaring both sides, giving us z squared is equal to 5z minus 4. This is a quadratic equation, so we're going to solve it by moving everything to one side. So we'll subtract z and add 4 to both sides. And now when we look to factor, the two factors of positive 4 whose sum is a negative 5, so minus 4 and minus 1. So the two possible values we get for z are 1 and 4. We want to check these. If we test 4, we get 4 squared. Is that equal to the square root of 5 times 4, which is 20, minus 4? So 4 squared, sorry, not 4 squared, just 4. Is 4 equal to the square root of 20 minus 4, square root of 16? Yes, that checks. Okay, do the same thing with 1. We take 1, set it equal to the square root of 5 times 1, which is 5 minus 4. Is 1 equal to the square root of 1? Also yes. And so our two solutions are going to be 4 and 1. Okay, let me talk through this second one here really quickly. Again, same idea. If this is the version that you see, isolate the radical, already done. Square both sides to get rid of the radical, giving you v squared equals negative 10v plus 11. Move everything to one side and set it equal to 0. So we add 10v and subtract 11. When we solve by factoring, the two factors of negative 11 that equal a positive 10 is a plus 11 and a minus 1. So our two possible solutions here are negative 11 and 1. When we plug those in, negative 11 is equal to the square root of, again, we don't need to go any further. Square root can't equal the negative, so that's extraneous. Test 1, 1 is equal to the square root of negative 10 times 1 plus 11, which is the square root of 1. That is a true statement. And so our answer for that middle problem would just be the 1.